1 2 3 4 5 ಅಣ್ಣ. Hello students, in our previous class we have discussed about dimension analysis, conversion of units from one system to another system. Okay, in today's class we are going to study about or discuss about laws of chemical combination. Your actual chemistry starts now. Here we have many laws of chemical combination. A chemical reaction occurs. There are many chemical transformations. You studied most of them in your previous classes or in your lower section. Okay. So those reactions, the chemical reactions that you have studied so far, they take place according to these laws, according to laws of chemical combination. Andre adike bekada hage react agಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. They have to follow certain rules. So they follow all these 5 rules and they undergo chemical reaction. ಅದಕ್ಕೆ ಬೇಕಾದ ಹಾಗೆ ಕಂಬೈನ್ ಆಗುವಂತಹ ಪರಿಸ್ಥಿತಿ ಇಲ್ಲ. So they have to obey all these rules. And that first law is law of conservation of mass. You might have studied this law of conservation of mass. Here what it says, matter can neither be created nor destroyed. So you cannot create a matter in an empty space. Empty space ನಿಮಗೆ matter ಅನ್ನು create ಮಾಡಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ. So ಏನಾಗ್ತದೆ, in a chemical reaction or in any transformations, both in physical as well as in chemical transformation, always the mass is conserved. You heard about law of conservation of energy. In the same way we define law of conservation of mass. Mass is conserved at the end of the chemical transformation. How? Look at this reaction. I have written one reaction. Here in this reaction I have taken 12 gram of carbon and 32 gram of oxygen. So I'll get 44 gram of carbon dioxide. So I have taken how much amount of reactant? I have taken 12 plus 32, total 44 gram of reactant for the reaction. So at the end of the reaction I have to get 44 gram of the product only. Okay, you cannot get 45 gram or 50 gram or you cannot get 30 gram of CO2. Okay, this is a balanced chemical equation. So you cannot create a matter by your own. ನಿಮ್ಮದೇ ಸ್ವಂತ matter ಅನ್ನು empty space ಅಲ್ಲಿ create ಮಾಡಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ. Okay, and even you cannot destroy a matter. You cannot destroy a matter. Destroy ಮಾಡಕ್ಕಾಗಲ್ಲ means you cannot decrease the mass of the matter. So you can convert the matter into various forms. Then you convert ಮಾಡಲಿಕ್ಕೆ ಆಗ್ತದೆ, but ಅದನ್ನು destroy ಮಾಡಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ. Means you cannot destroy the mass. Matter destroy ಆಗಬಹುದು, but ಅದರ mass ನೀವು ಎಷ್ಟೇ destroy ಮಾಡಿ, the combined mass of all the things remain what equal to the original mass itself. ನೀವು destroy ಮಾಡೋದಲ್ಲ. For example, if you take this marker, you can destroy this, but you cannot destroy the entire mass of this marker. The mass of the marker after the destruction also remains the same. Understood? So this is about the law of conservation of mass. Matter can neither be created nor destroyed. One more example if you want. H2 plus half O2 gives you H2O. So very familiar reaction. In this reaction, you have to remember the molecular mass of hydrogen, that is 2 gram, plus molecular mass of oxygen is 32 gram. Since we have taken half moles of oxygen, I'll write it as 16 gram. So total mass of the reactant before the reaction is 18 gram. Okay, after the combustion of this hydrogen, I will get 18 gram of water again. So you cannot destroy the entire mass of water. Understood? This is about the first law, law of conservation of mass. It's very similar to the law of conservation of energy. Second one, a law of definite proportions. So what it says, a given compound always contains exactly the same proportion of elements by weight. So how do you explain this? This is very simple. We can prepare various compounds by using different kind of methods. Okay, here I have given one example, but one more example I will give you. How do you prepare carbon dioxide? By combusting carbon or hydrocarbons. By combusting carbon or burning carbon, I can prepare carbon dioxide. This is not only the one method. There are many methods for the preparation of carbon dioxide. It is produced during the respiration process. Okay, respiration process ಅಲ್ಲಿ ಕೂಡ carbon dioxide produce ಆಗ್ತದೆ, and even by the decomposition of calcium carbonate. Okay, ಸುಣ್ಣ ಅಂತ ಕೇಳಿದ್ರೆ by the decomposition of calcium carbonate, you will get CO2 again. So we can prepare CO2 in various reactions, or it is obtained as a side product of many chemical reactions. Here, the composition of CO2 obtained by various chemical reactions, okay, that is not going to change, that is definite here. It says a given compound, what is given here? CO2 is given. The given compound always contain exactly the same proportion of elements by weight. Okay, in terms of percentage or in terms of weight, always the mass or weight of these things must be same. Here we have 44 gram of carbon dioxide. Here also the mass of what? CO2 is 44 gram. Here also the mass of CO2 is 44 gram. How? Due to the presence of 12 gram of carbon and 32 gram of oxygen. In all these CO2 molecules, the mass of carbon is 12 gram and mass of oxygen is 32 gram. That's what this law says. Given compound always contains exactly the same proportion of elements by weight. Here CO2 contains same proportion of carbon and oxygen. In this method also, for example, if you prepare CO2 by this method, here also I have 12 gram of carbon and 32 gram of oxygen. During the respiration also you obtain CO2. So here also the amount of carbon is 12 gram, amount of oxygen is 32 gram. By the decomposition of calcium carbonate also I obtained carbon dioxide. If you measure the composition of carbon, it's equal to 12 gram. Composition of oxygen is equal to 32 gram here. So this is what the law says. One example, okay, you can write any example. This one also you can write, or this one you can write. Cupric carbonate. Okay, it's naturally available as well as synthetic compound. By treating copper sulfate with calcium carbonate, you will get cupric carbonate. The natural cupric carbonate contains 51.35% of copper, 9.74% of oxygen and 38.91% of carbon. So this is the composition of copper, oxygen and carbon in cupric carbonate, naturally available cupric carbonate. The synthetic cupric carbonate also has the same proportion of elements by weight or by percentage. Understood? Here they have converted weight into percentage. Otherwise you can write it in terms of mass also, no problem. Errorly kuda baribodu, in terms of percentage baribodu, in terms of mass baribodu. So errorlu kuda enitte nodi, naturally available cupric carbonate as well as synthetic cupric carbonate, both are having equal proportion of elements by weight or by percentage. Okay, this is about law of definite proportions. This will be asked for 2 marks. Very important. All the laws are very important for 2 marks. Definitely they will ask one question from this part. 100% you can expect one question from laws of chemical combination. Okay, moving into law number 3, law of multiple proportion. Okay, carefully observe here what it says. If 2 elements can combine to form more than one compound, okay, by the combination of 2 elements we may get many compounds. Okay, if 2 elements can combine to form more than one compound, the masses of one element that combined with the fixed mass of another element are in the ratio of small whole numbers. Okay, once you go through it, once you read it, then you can understand. So here's, if 2 elements can combine to form more than one compound, I have given one example here. See, I have taken 2 elements, hydrogen and oxygen. They are going to combine, okay, and they form 2 compounds. Here in first example, H2 is going to combine with O2 and it's going to produce H2O. Here 1 mole of H2 combines with half mole of oxygen to produce 1 mole of H2O. So this is the first reaction. Again the same 2 elements, they combine and they are going to produce a new compound. This is known as hydrogen peroxide. Hydrogen peroxide. So disinfectant. See, the same elements are present in both the reactions. ಎರಡು reaction ಅಲ್ಲಿ ಕೂಡ ಇರುವಂತ elements ಗಳು same ಇದೆ. But the proportionally ಏನಿದೆ ನೋಡಿ, here H2 is same but the proportion of what? Oxygen is different. That's why it's going to produce different type of compounds. Difference ನೋಡಿ. First part ನಿಮಗೆ ಅರ್ಥ ಆಯ್ತು. If 2 elements can combine to form more than one compound, ಇದು first part ಅಲ್ಲಿ explain ಮಾಡಿದೆ. There are 2 elements, they are going to form what? more than 2 compounds. ಇಲ್ಲಿ ಎಷ್ಟು ಕಾಂಪೌಂಡ್ ಫಾರ್ಮ್ ಮಾಡಿದೆ? 2 ಕಾಂಪೌಂಡ್ಸ್ ಫಾರ್ಮ್ ಆಗಿದೆ. ಸೆಕೆಂಡ್ ಪಾರ್ಟ್ ಏನು ಹೇಳ್ತದೆ ನೋಡಿ, the masses of one element that combine with the fixed mass of another element. So mass of which element here we have to take? Here the mass of which is fixed. The mass of oxygen in both the reactions are fixed. Okay, so mass of hydrogen is 2 gram here. Here also mass of hydrogen is 2 gram. Masses of hydrogen both the reactions are fixed. So now see, the masses of one element that combine with the fixed mass of another element means mass of what? Mass of oxygen. Here mass of oxygen, because oxygen is going to combine with fixed mass of hydrogen. So now here we write the masses of one element, that is oxygen, that is going to combine with the fixed mass of hydrogen are in the ratio of small whole numbers. So what is the mass of oxygen in first reaction? That is 16 gram. What is the mass of oxygen in second reaction? That is 32 gram. So what is the simple ratio? That is equal to 1:2. So this is the law of multiple proportion. Here it is given masses of oxygen, that is 16 gram and 32 gram, which combine with the fixed mass of hydrogen have simple ratio 16:32 or 1:2. So this is what? This is law of multiple proportion. Okay, if you want, I will give one more example here. I will give one more example. Carbon plus oxygen. What you will get? Carbon dioxide gas. Similarly, C plus half O2. So you will get carbon monoxide. So mass of carbon is 12 gram. You need to remember all these things. This is 32 gram. This is 44 gram. So here mass of carbon is 12 gram. So this is 16 gram. So this is how much? 18 gram. 28 gram, sorry, 28 gram. Now look into this reaction. Here mass of carbon is fixed. It's 12 gram. Now this oxygen is going to combine with the fixed mass of carbon. So now the masses of this oxygen base a small whole number ratio. How? You can write it as 32:16 or you can write 2:1. You can give any example here. Okay, either you can write the example of formation of water or formation of carbon dioxide and carbon monoxide. So this is about law of multiple proportion. Next, the next law is Gay-Lussac's law. So this law is applicable only for gaseous reactants and products. So what it says, when gases combine or produce in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. This is the definition which is given in your NCERT textbook. You can change this definition like this: when gases are combined or produced, there exists a simple ratio between the volumes of gaseous reactant and product at same temperature and pressure. So you can modify like this in order to simplify this. You can start from here also. At same temperature and pressure, there exists a simple ratio between the volumes of gaseous reactant and product. You can write like this also. Okay, so now I'll give you the example. Hydrogen plus oxygen gives you water. You know this reaction, H2 plus half O2 gives you H2O. You know the molar ratios and all. If I take 100 ml of water, so I have to take 50 ml of oxygen. Why? Because we have only half mole of oxygen here. So now, according to this law, there exists a small whole number ratio between the volumes of oxygen and hydrogen. So what is that? Small or simple ratio. So that is 2:1. 100:50 or 2:1 ratio is present. Understood? So one more example. H2 plus Cl2. Both are gases which are going to produce 2 HCl. Now according to this law, when gases are combined, here H2 and Cl2 are going to combine and they produce 2 HCl. So what it says, they do so in a simple ratio by volume. So now there exists a simple ratio between the volume of these two gases. For example, if I take 50 ml of H2, I have to take 50 ml of Cl2 also. So 50 ml of H2 and 50 ml of Cl2 produces 100 ml of HCl. Why? It is 2. This is 1, this is 2. So now there is a ratio 1:1. or if I take Cl2 and HCl, the ratio is 1:2, 50 is to 100, so the ratio becomes 1:2. So the ratio, the simple ratio is present between the volume of gaseous reactant as well as between the reactant and product. Okay, so this ಸರಿಯಾಗಿ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. So ಹೇಗೆ ಚೇಂಜ್ ಮಾಡಿ ಬರಿಬಹುದು? So when gases are combined or produced, there exists a simple ratio between the volumes of gaseous reactant and product at same temperature and pressure. Understood? ಆ ಎರಡು ಗ್ಯಾಸಸ್ಗಳು ಕೂಡ ಸೇಮ್ ಟೆಂಪರೇಚರ್ ಮತ್ತೆ ಪ್ರೆಷರ್ ಅಲ್ಲಿ ಇದ್ರೆ ಸೊ ಅದರ ಮಧ್ಯೆ ಏನಿರಬೇಕು, ಆ ಸಿಂಪಲ್ ರೇಷಿಯೋ ಇರಬೇಕು. ದಿಸ್ ಇಸ್ Gay-Lussac's law. The next law is, the last one is Avogadro law. So what it says, this is very important. Equal volume of gases at the same temperature and pressure contains equal number of molecules. So this law is very, very important. I think you might have heard about the term STP, standard temperature and pressure. So you remember this example in next chapter, or in chapter number 6, states of matter, you are going to study about what is STP, what's molar volumes and all. I'm not going to discuss it now itself. At STP, at standard temperature and pressure, I have taken two gases H2 and O2 at STP, at standard temperature and pressure, at 273 Kelvin temperature and 1 atmosphere pressure. So these two gases, the volume of these two gases is equal to 22.4 liter. At STP, H2 and O2, volume of H2 and O2 is 22.4 liter, and these two gases now possess 6.02 into 10 to the power of 23, 22 into 10 to the power of 23 molecules. This is Avogadro number. 6.02 to 10 raised to 23 is known as Avogadro number. Understood? So this is the example. One more example I will give you. I'll take three containers A, B, C. A, B, C. In this container I'll take O2, in this container I'll take N2, in this container I'll take H2. So the volume of this container is 1 liter, this container is also equal to 1 liter, this container is also equal to 1 liter. Mooru container volume is 1 liter irtade. Now at a given temperature and pressure, I'll take at 25 degrees Celsius, that is at 298 Kelvin temperature. It's just an example, and 1 atmosphere pressure. The number of molecules present in container A is equal to number of molecules present in container B, which is equal to number of molecule present in container C. That is, number of molecules of O2 is equal to number of molecules of N2, which is equal to number of molecules of H2. In all these three containers, number of molecules are same because we have maintained 298 Kelvin and 1 atmosphere pressure in all these three containers. Okay, during that time, Avogadro, okay, he was not knowing about the concept of molecules, atoms and all. So this is a diatomic molecule. If I take an atom like this, now instead of molecules we have to write atoms. So what? Equal volume of all the gas at same temperature and pressure contains equal number of atoms. Okay, here O2 has 6.022 into 10 to the power of 23 molecules. How many atoms it has? One molecule has 2 atoms. So total number of atoms is equal to 2 into 6.022 into 10 to the power of 23. So there are polyatomic molecules are also present. Okay, regarding about those we are going to discuss in our next video. Okay, this is about laws of chemical combination. Remember, this is very, very important. Equal volume of gases at same temperature and pressure contains equal number of molecules. Okay, temperature and pressure of all the gases, taken gases must be same. So now they must have equal number of molecules. Okay, this is about laws of chemical combination. Thank you.